In today's session, we are going to study about your decision tree induction and your rule-based classification. Now, first, let's start with your decision tree induction. What do you mean by decision tree induction? Tree. What is a tree? A tree has what? A root node, an internal node, and the branches. Yes or no? Or the leaf nodes. Now, what do you mean by decision tree? Here, the decision tree is same like your normal tree. Your decision tree also contains your root node, internal node, and your leaf nodes. Fine. See, you all can see here. Now, this is your root node. Then this is your internal node. Then this is your leaf node. This is not the same like your tree. Yes, it's similar to your normal tree. So in the same way, you have your root node, you have your internal node, and you have your leaf node. Now, why are we using this decision tree? What is the use of this decision tree? I'll give you a small example. I'll walk into a store to buy a pen. Okay. Now, I have chosen different types of pens. Okay. From that one I have taken. After taking that, what do I see? I'll check for my price. Now, after seeing the price, now it's my wish or my opinion to whether take that pen or not to take that pen. Here I have what? Two cases. Yes or no. So this is nothing but a decision. Now about a pen, to buy it or not to buy it, I have to take a decision. That is nothing but my decision tree. It's just a simple example. Now why are we using this? Now what is the use of this? See, when I tell you randomly like this, are you able to understand? No. Now same thing, if I draw it in such a way that here I'll be telling I have a pen. Now I am buying it. Yes, buying. Now, are you able to understand? Yes. Now, for same, I have another scenario here. I am telling I am not buying. Okay. So, what is happening here? For the same pen, I am telling yes, I am buying. No, I am not buying. So, this is nothing but a tree. If you see all this, you can simply understand, yes, you have a structure wherein you can understand. Even a layman, a human being who doesn't have any understanding about it can understand whatever I am telling. See here, why decision tree? Decision trees usually mimic human thinking ability while making a decision. So it is easy to understand. Now, the logic behind the decision tree can be easily understood because it shows a tree-like structure. A decision tree is supervised model. When I was talking about your supervised and unsupervised labeling, then I told you in supervised you have your classification. In classification, when I'm talking about your model construction and model usage, there I have told you about your classifier algorithms. One of the classifier algorithms is your decision tree. So I'm using your supermodel to predict what target by learning the decision rules. Now what is the target here? Your target is yes or no. That is the final result, whatever we have. As the name suggests, what are we doing? We are breaking down the model by the data, whatever we are having, and we are taking a decision out of it. Next, in general, what is happening? You have different steps. Like basically, we do a priori algorithm in two ways. One is your normal decision tree, and one by using your ID3 algorithm. Now, when I'm talking about your normal decision tree, what am I doing? I'll give you a small example here. See, I have student name, I have student marks, and I have result. Okay. So my student name is A, B. Two students I have. Marks are 30 and 75. These are 2 marks. When I am coming to the result, one is fail, one is pass. Now, according to the previous this thing, if you all can see, what am I telling? It's based upon what? Target. Predicted target by learning decisions. Now, out of this, what is the target I have? My result is the target. Yes or no? So, now, do I really require this marks now? No. If I say student name A has failed the exam, it's enough, right? I don't require marks now. My target is only to know whether my student is pass or fail. So what do I do here? My student name is a tree. My student name is a tree, and I have two things about the target. One is what? Is my pass, and other is my fail. Yes, this is what is your simple decision tree. Now, when I am talking about your ID3 algorithm, so what am I doing in ID3 algorithm? First, I have a set of root node. Let me take S as my root node. Next, I'll do iteration of the algorithm by using what? Your two things. Entropy, and next is your information gain. These two are very important. Two things, what am I doing? One, entropy, and other is the information gain attributes. Based upon this only, I am going to solve my decision tree induction problem. Now, then select attributes which are smallest entropy or largest information gain. Next, the set S is then split by the selected attributes to produce a subset. Now subset, when I'm talking about the this one, when your student name, now these are my subsets. So that's what I'm telling them. Now the algorithm continues to recur on each subset considering only attributes never selected before. Okay, now let's see. Now, how do you select the attributes? How do you select the attributes? What are the attribute selection measures? Now, if I have a n attributes, consists of dataset consists of n attributes, then how do I decide? I'll be deciding it. What are the internal nodes? What is the root node? Everything based upon two things. One is your entropy and second one is your information gain. Based upon this two only, I am going to decide what should be the root node, what are the other leaf nodes or the branches, whatever a tree can have. Now, what do you mean by entropy? In simple, entropy is nothing but uncertain attributes or uncertain data sets are nothing but your entropy. Information gain is addition of all your entropies gives you the information gain. Okay, now let's see. Entropy is what? Entropy is a measure of the randomness in the information being processed. Next, information gain is what? Information gain or IG is a statistical property that measures how well a given attribute separates the training examples according to the target classification. Now, in the previous simple example, whatever I told, result would be my target classification. Based on that only, I am eliminating what? I am eliminating my marks there. Now, to construct that, you have to know about your information gain. Information gain is what? Entropy minus your entropies. What are the attributes you have? Now, information gained is equal to entropy before minus entropy of whatever after you have. Now, let's see a simple example of your decision tree. I have a problem with age, competition, type and profit. These are the attributes I have. Now, if you all can see in age, I have old, middle and new. In competition, I have Y, N, Y, N, Y, N, N. Now, what are these Y, N, N, Y, Y, N, N? These are all yes. Old is participating or not participating. Yes is participating. Down is not, N is not participating. Coming to the type, you can find software and hardware. Their type of job. Let's take their type of job is software and hardware. Profit, down or up. This is about the basic question, whatever you got. Now, how are you going to find the entropy? First, you are going to find the entropy. The formula for entropy is minus P by P plus N log base 2 P by P plus N minus N by P plus N log 2 into N by P plus N. Now, what is this P? What is this N? P is number of downs you have according to this question, and coming to N, N is number of ups you have. Done? This is the basic formulae which is important to find the entropy. Minus P by P plus N log base to P by P plus N minus N by P plus N log to the base to N by P plus N. Now let's go into the example now. Now I told you P is what? P is your number of downs, N is your number of ups. Now first let us know how many olds we have, how many middles we have and how many news we have with respect to down and up. Okay. Now with respect to old, see how many downs you have? 3. How many ups you have? 0. Let's go back. You can see it here only. See, old, how many yes you have? 1. See, old, profit, down, 1, 2, 3 downs. Yes, you have 3 downs here. Do you have any up? Do you have any up? No, you don't have any up here. Then, coming to the next one, that is middle. In middle, how many downs you have? You have here 1 down, here 1 down, 2. How many ups you have? Here 2, here 2. Totally you have 2 ups and 2 downs. You can see towards the left, 2 ups and 2 downs. Next, new. For new, how many downs you have? Do you have any down? No down. So 0. How many new ups you have? 3 ups. 1, 2, 3. 3 ups. Done. So if you all can see, this down and up classification I have done. Now what is the entropy formula? Minus P by P plus N log base 2 into P by P plus N minus N by P plus N log base 2 N by P plus N. Here I told you what is P and what is N. Yes or no? In P is what? Is your number of downs. Now how many number of downs you have? 5. How many ups you have? 5. Count here. Towards the left. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes or no? 5 and 5 total. Now I want to find it. So how do I find entropy before split? Before splitting, what is the entropy? What is P? 5. 5 by P plus N. P plus N is total number of transactions I have. How many transactions I have? 5 plus 5. 5 ups, 5 downs. So totally 10. This is what is my minus 5 by 10 log base 2. P is 5 by 10. Minus again N is also 5. 5 by 10 log to the base 2. 5 by 10 which is equal to. And when I calculate this log, I will get a value as 1. Done. Now, first thing what I have to find, entropy of age, because here if you all can find, I have done this based upon the what? Age only, right? All the 3, old, middle and new, I have done it based upon the age. Now entropy of old separately, entropy of middle and entropy of new. So how do I get old? Old, my down is what? 3. Down is what is? 3. 3 by 3 log base to 3 by 3 minus, do I have any ups? No. So 0. 0 by 3 log base to 0 by 3 into 3 by 10. P of I into N. This is what is your this thing. Is E which is 0. I'm using this formula. Here 3 is your what? Ups. Why it is 0 here? Because I don't have any ups here. Here 3 is your down. Here I don't have any ups. P plus N. So P plus N is 3 plus 0 which is 3. The same thing is applicable here. Now middle. In middle what is happening? I have 2 ups and 2 downs. So the same thing. 2 by 4. Why it is 4? P is 2, N is 2. So 2 plus 2 is 4. 2 by 4 minus 2 by 2. Again, this is your 0.4. Next for new is your 0. Now you have got entropy for what? Old, middle and new. So now what you have to find? You have got the entropy. After getting the entropy, what you have to do? You have to find your information gain. Now, what is your information gain? Information gain is equal to total entropy minus your entropy of old minus entropy of your middle minus your entropy of new. Done. So now let's check that. See now, E of A is what? First, here we are calculating what? Entropy, total entropy. As I told you, we need to get Ig is equal to what first? Entropy total. To get the entropy total, what am I doing? I am adding all the three. I have got all the three values. Done. Now, you can check here. Now, information gain is what? Entropy before minus this. So, that's what I told you. 1 minus your E of A. Your E of A is what? 0.4. I have got a value. In the same way, now, done. Now, let's see how we are going to do it. Next, I have done it for what? My competition and my type also. See, E of C is nothing but the competition. Done. And E of T is nothing but my type. The same thing how I have done for age. Here, what am I going to do when I'm talking about competition? I will be taking what? Y, N. Two variables. Yes. Again, I have down. I have up. Now, how many, when it is Y, how many downs I have? Check that. When it is Y, for Y I have 1 down. For Y I have 2 downs. 3 downs. When it is Y, I have 3 downs. Now, when it is Y, how many ups I have? I have only 1 up. Done. I have only 1 up. Now, when I am talking about N here, N is no. No for how many no's, how many downs I have? 1, 2. I have 2 here. Done. Again, here how many I have? Ups for no's? 1, 2, 3, 4. Done. This is what my table is. Again, for this table, now this is what my table is. Again, for this table, I need to find again my entropy with the same formula. With this formula, I need to find the entropy. After finding all that, I have got my competition at 0.86 and I have got my type as 1. Now, out of all this, when I am checking what is the highest, when I have having like this, I need to check with the highest Ig. What I have to do? I need to check with highest Ig out of all the values I have got. Now, out of all the values, what is the highest Ig I have? It's 0.6 for age. So, I'll be taking age as my what? Root node. Now, after this, what I have to do? Now I have got age as my root node, right? So now, the next thing what I have to do is, for my age, do I have anything? When I am talking about old, middle and new. You can check here, old, middle and new. When I am talking about old, do I have any ups? No. Only I have one decision, that is 3. When I am talking about new, I have only one decision, that is what is up. Here when I am talking only about old, I am having only one decision as down. No, I don't have any conflict now. Do I have any conflict? No. I have only single opinions that if it is old, it is down. If it is new, it is up. So that's the reason I have drawn it directly. You all can check. See, I have age. For the age, I am doing it for down and I have up. Now, when I have middle, in middle what is happening? I have 2 ups and 2 downs. So, for that, again I need to follow the exactly all the steps whatever I have done here. Now, complete for the competition, all the things, whatever I have done. First, I'm going to find the entropy. Next, I'll be getting the entropy value. For that entropy value, for that competition, I'll be finding the information gain. If I find the information gain, then I'll get what is yes, what is no. Then I'll be drawing it. This is my final result. This is how my tree looks. This is all about your decision tree using ID3 algorithm. For example, if they give you this diagram, this question, and they don't ask you as ID3 algorithm, so what do? Basic thing. First you have age, right? Put the age. Under age, what do you have? What do you have? You have your, as I told you, you have your down, you have your up. Yes, for age I am done. Next, what is the different attribute you have? You have your competition. Yes, for the competition, what do you have? Again, you have your software, hardware. Yes, again for the software, hardware, for your competition, you have what again? For the competition, you have your, for your age, you have your old, what do I call, middle and new. Yes, for your old, do you have anything? No, you have only down. For your new, you have only up. Done. When I'm talking about this, you have what? Both your old and new. Then comes with my competition, the other node. Here you have middle. Now competition. In competition, what do I have? I have yes and no conditions. For that, again I'll check what is yes, what is no. If it is yes, it is down. If it is no, it is no. Then what do I have? I have a type. In type, what I have? I have a software, I have a hardware. Now again, which is down, which is up, I'm going to draw. This is your basic decision diagram for this question. Now, I am doing everything. If I want to write it in the phrase, how do I write? I want to write it in a line, final result. So how do I write? For writing that in a line or in a sentence, we have a concept called as rule-based classification. In that rule-based classification, I'll be talking about your if and then conditions. Basically, your rule-based classification uses your if and then condition, wherein we use this if and then conditions in what? Again, in your decision trees. Now, if you all can see the diagram, if age is old, then it is down. If age is new, then it is up. If age is middle, then they are participating in the competition. After participating in the competition, it is yes or it is no, either of the condition. So like this is called as your rule-based classification. Now, using if-then rule for classification, representing the knowledge in the form of if-then rules. If age is equal to youth and student is equal to S, then buys computer. The same thing, whatever I told. Rule, antecedent or precondition versus your ruled consent. Now, assessment of a rule is what? Coverage and accuracy. How are you doing that? You have a tuple covered by R and the classified, whatever the classified you have. Basically, remember one thing, whatever you write, you have to write like this. If something is equal to something and something is equal to something, then you are doing something, you are getting finally a target value. This is what your rule-based classification talks about. If more than one rule is triggered, then what happens? Obviously, a conflict occurs. What might be the conflict? It might be your size ordering or your class base, like you need to write list within a list, everything. Such type of things may happen here. Now, rule extraction from a decision tree. How are you extracting it? See, you can see a simple example. Age less than or equal to 30, 31 to 40 and greater than 40. Is a student? Yes. Credit rating. You have some decision tree here. Now I need to write rules for this decision tree. So how am I going to write? Rule extraction from one buys for our buys computer decision tree. If age equal to n and student equal to no, then what? Buys nothing. No. If age equal to n, student equal to, then buys computer. Yes. If age equal to middle age, then what? Buys computer. Yes. So I am using a if and then conditions. I am using what? Your if and then conditions to write this. This is nothing but your rule-based classification. So in today's session, what did we do? We have learnt about your decision tree induction, how we are simply going to draw a decision tree, and your ID3 step-by-step algorithm, and we have seen what is entropy, how you are going to calculate entropy, and how are you going to calculate your information gain.